In Chapter 2, we need to talk about average rate of change. One topic that this builds on is your understanding of slope. When we're working with a straight line, we can calculate the change in y over the change in x. I'm going to just put this here as a reference. Or rise over run. It's also another way that we calculate that. If we're working with a straight line, this is how we calculate the slope of a line. But we're not in this section of the text, where we're looking at functions, polynomials that are curved, higher degree polynomials like quadratics, third degree, fourth degree, and so on. We're most familiar with quadratics, so let's use a quadratic as an example. Let's suppose that we have f of x equals 2x squared plus 12x plus 14. We have just talked about transformations in the previous section, and so what I want to do is show you how we can learn a little bit about this polynomial, this quadratic, by completing the square and then taking our new knowledge of transformations. So completing the square, let's factor the 2 out of these first two terms. So we'll have x squared plus 6x. And remember, we make room for the term so that this is going to be a perfect square. But then we still have this 14, and whatever we add inside of these parentheses, it's going to be multiplied by 2, so we're going to need to subtract the same amount that's been added inside here times 2. Anyway, half the linear coefficient squared is 9, and 2 times 9 is 18, so we're going to need to subtract 18. So 14 minus 18 is negative 4. Now, we haven't talked about these quadratics in this way before, but now that we've talked about transformations, I want you to think about something. You know what the function x squared looks like. It has an origin at 0, but what if we did x plus 3 squared? You know that's a horizontal shift 3 units to the left, right? So here the origin is at 0, 0. This one, the quadratic, is shifted 3 units to the left. So now the origin is at negative 3, 0. Well, you also saw when we were working with transformations that when we subtract after the function has been operated, so in this case after the square, if we subtract 4, this moves it down 4 units. So this adding 3 inside before the square, that's going to shift it left 3 units. This is shifting it down 4 units. And then finally we have this 2 out here. Well, the 2, let me slide down here. Well, I guess we have room over here, sorry. The 2, as you know, that's amplifying, that's multiplying, and this is going to increase because it's outside of the function. This is going to increase the rate at which the function moves vertically. Okay, so this is just going to make it increase faster, which is going to make the parabola appear to be narrower. The important thing to remember here is we started out with an origin at 0, 0, but because we're shifted 3 units to the left and 4 units down, the origin is now at negative 3, negative 4. Okay? So let me do a real quick sketch of this, and then we'll talk about average rate of change, calculating the average rate of change for sections of this parabola. So negative 3, negative 4. Okay. Another thing to think about, when x is equal to 0, we can go back up here. That's going to be 0 plus 0 plus 14. So it's going to cross over the x-axis pretty high up here. That's kind of beside the point right now, but anyway. So it's coming down pretty thin, and it goes back up again. Okay? Now, obviously, the slope over here, or the average rate of change, this is a negative. This is a decreasing portion of the function. And then here, the function makes this drastic turn, and now the function is increasing. So if we think about it, that, like I said before, there's not a constant slope. However, let's think about this. Let's think about what happens between -6 and -3. What is the average rate of change, or the average slope in this quadratic as we go from -6 to -3? Okay, so between -6 and -3, we're going to figure out the average rate of change. Well, let's start with this. Let's figure out the value of the function when x is equal to -6, and then we'll figure out the value of the function when x is equal to -3. Okay, obviously one of these is easier than the other. We already know that when x is equal to -3, -3 and 3 is 0, so the function is just equal to -4. Okay. When it's equal to -6, let's just jump back up to here. -6, that's going to be 2 times -6 squared, which is 36, plus 12 times -6. 12 times -6 is going to be -72. And then plus 14. Okay. Notice anything? 2 times 36 is 72. Minus 72 is 0 plus 14. Didn't we just say that when x was 0, it went through the axis at 14? Yeah, when x is 0, the function is equal to 14. Remember, a parabola like this is symmetric. And if you move 3 units to the right, it crosses at 14. And going through -6, that's just 3 units to the left. So what should the value be? It's going to be 14 again. So the point here is that when x is -6, it's 14. And when x is -3, the value of the function is -4. So back to what I was saying earlier, we can figure out the slope, but it's not slope again, because it's the shape of this is curved, and so the slope, the rate of change, is always moving. So instead we calculate what's called average rate of change. And here you go. This is how we do it. The average rate of change is equal to the difference, or the change in the function, over the change in x. Or let me say it this way. We could calculate the change in the function between two values, a and b. Well, that's exactly what we have here. We have two values for x. We have -6 and -3. So if we wanted to figure out the average rate of change between -6 and -3, that would be f of -6 minus f of -3 divided by -6 minus -3. And we've already figured out these values. We've got 14 is the value of the function when x is -6, and -4 is the value of the function when x is 3. And then -6 minus a -3, that's going to be -6 plus 3, so that's just 3. And 14 minus 4 is 10, and so this is, 14 minus a -4 is actually going to be 18, and this is 3, and so the average rate of change is 6. Now, one more thing. I need to point out that this actually does have a little bit more to do with slope than maybe we're giving credit for. Here is the value of the function when x is equal to -3. And let's suppose that up here, this is the point -6, 14. So what is this? I'm sorry, this is -3, this is -3, this is -6. Slope over here is negative, right? It's a decreasing. So what are we saying when we say the average rate of change is -6? I want you to think about this. A new word maybe for you. I want you to think about this in terms of the slope of the secant line. Secant line, what's a secant line? A secant line simply connects 2 points on a curve. So if we go from -614 down here to -3, -4, if we connected those 2 points with a straight line, the slope of that straight line would be -6. So the average rate of change between 2 points on a function let me write this out for you. The average rate of change between 2 points on the graph of a function is equal to the slope of the secant line connecting those 2 points. Okay? In the next video I will give you another example or two.